off that when we were finding the x and y intercepts, if we want to find the x-intercept, we plug in 0 for what? Y. And when we want to find the y-intercept, we plug in 0 for x. So now we're going to do some sample problems so to mix all this knowledge together. And the first sample problem is asking us, I'm giving you 3 different points and I'm asking you, are they collinear? So now I'm bringing the geometry into this. Who remembers, it's back from chapter 1. What does it mean if points are collinear? Good, they exist on the same line. So if points exist on the same line, wouldn't they all have to have the same slope between them? So what we're going to do is we're going to check their slopes. If their slopes are the same, then they're all on the same line. If their slopes are different, then they are not on the same line. So we are going to start off by checking. You only check 2 points at a time. There's no way to check all 3. So I'm going to start by checking -6, 5, and 1, 7. And remember, our slope when we're given 2 points is y2 minus y1 over x2 minus x1. So the slope for these 2 points is going to be y2. So I'm going to call this x1, y1, x2, y2. So I'm going to have 7 minus 5 over 1 minus, it's not going to be 1 minus 6. It's 1 minus what? -6. 1 minus a -6. And this double negative makes a positive. So we end up with this slope being, and bring it up here, 7 minus 5 is 2, and 1 plus 6 is 7. So my first slope is 2 over 7. So now when I check the combination of all the other points, what should it all reduce down to? 2 over 7. And if it doesn't, what does that mean? Then they're not collinear. Exactly. So now I check -5, -6, 5, and 1, 7. What do you want to check next? Okay, let's check 1, 7 and 15, 10. So I'm going to do 10 minus 7 over 15 minus 1. So 10 minus 7 is 3. 15 minus 1 is 14. Can I stop here? Yeah, because I got 2 different slopes. Let's say I got the same slope. Could I have stopped there? No. What then would I have had to check? You got it. And then if all of those were the same, then we'd be collinear. But we can stop the minute one slope is different. So we're going to say not collinear because different slopes. Okay, the next one. So don't write this down, but do you remember when we were first talking about y equals mx plus b, I was asking you what these variables stand for. You guys told me that m is the slope. You told me that b is the y-intercept. What do x and y represent? Who remembers? We said m was the slope, b was the y-intercept, but x and y also represented something. Good. All the points that exist on the line. X and Y represent all the points that exist on the line. Why am I bringing this up? Because in this next problem, I'm asking you, does the point 4, -1 exist on this line? Now, this is an equation of a line. Is it in slope-intercept form? No. If we wanted to, could we put it in slope-intercept form? Sure, but we don't have to. If it's going to be a point on the line, what we're going to do is we're going to plug in 4 for x, we'll plug in -1 for y, and if the left side equals the right side, then it's a true statement. If the left side doesn't equal the right side, then it's not a true statement, and this point is not on the line. So I will write down what I just said. Plug point in for x and y in the equation. If left side equals right side, point is on the line. So now I'm going to plug in 3 times x. Well, what's my x coordinate? 4. Minus 2 times y. My y coordinate is -1. And we want to know, does that equal 10? So we're going to have 3 times 4 is 12. -2 times a -1 is a +2. Does 14 equal 10? No, since this is not a true statement, what does that mean? It is not on the line. The point for -1 is not on the line. There she is. Hi. At least you're going to be here for a period. Okay. So for this next one, it says find the equation of the line with a slope of 3 and an x-intercept of 5. So when I ask us to find an equation of a line, I'm looking for us to write something in y equals mx plus b form, if we can. And in order for this equation of this line to make sense for us, we need a number for m and we need a number for b. So here it's saying we want to write an equation of a line with a slope of 3. Well, do we agree if the slope is 3, that's m, our m is 3? And they're saying, oh, an x-intercept of 5 is b. Does b represent the x-intercept? No, what does b represent? The y-intercept. So when they say an x-intercept of 5, they just mean the point 5, 0. That's what the x-intercept of 5 means, the 0.50. So I know I have y equals 3x plus b because they told us the slope was 3. Is this good enough for this to be an acceptable equation of a line? It's not good enough. Do we all agree I still need a value for b? All right. So remember, m is the slope, b is the y-intercept. What do x and y represent again? All the points that exist on the line. Well, isn't it telling us the 0.50 exists on this line? So what I want to do is I want to plug in the 5 for x, I want to plug in the 0 for y, and then I'm going to solve for b. So I'm going to plug in 0 for y, 5 for x, and I'm going to solve for b. So this is going to be 0 is equal to 3 times 5 plus b. So 0 is equal to 15 plus b. So what does b equal? Negative 15. So the equation of this line is going to be y equals 3x minus 15. Okay, for this next one, I'm giving you 2 points. Once again, I need it to look like y equals mx. Guys, I need you to stop talking. I need it to look like y equals mx plus b. We need a number for m. We need a number for b. But I'm only given 2 of the points that exist on this line. But if I'm given 2 points, can I find the slope using 2 points? So that's the first thing we want to do. Step 1, find slope using formula. So we're going to have m is equal to y2 minus y1 over x2 minus x1. So our slope is going to be 1 minus negative 3 over 4 minus 7. That double negative makes a positive. So I'm going to have 4 over negative 3. That's my slope. So the first step was finding your slope. The second step is going to be plug in slope and one of the points given into y equals mx plus b and solve for b. Okay, so what do I mean by this? I mean we're going to take y equals mx plus b, and we just found the slope. What was the slope? Good. I'm just going to assign the negative to the numerator, so I'm going to say negative 4 over 3. And then what I'm going to do is take one of the points, either 7, negative 3, or 4, 1. It doesn't matter which one I choose. Unfortunately, neither of these will work out very nicely. So I'll just choose the smaller numbers, 4, 1, and I'm going to plug in 4 for x, and I'll plug in 1 for y. So I'm going to have 1 is equal to negative 4/3 times 4 plus b. Everybody okay with what I've done so far? All right, so now we're going to have to do some algebra work. So I'll bring it up here. So I have 1 is equal to negative 4/3 times 4 plus b. So we need to just multiply across here. Negative 4 times 4 is negative 16. 3 times 1 is 3 plus b. I need to solve for b. So do we all agree I need to get rid of the negative 16 over 3? How do I bring the negative 16 over 3 to the other side? Yep, we're going to add 16 over 3. So now I have 1 plus 16 over 3 equals b. I'm not going to leave it like this. I have to create a common denominator so I can add them. So I'm going to multiply top and bottom by 3. So we're 3 over 3 plus 16 over 3 equals b. So that gives us 19 over 3. Do we now have everything we need to write this equation? Yeah, so we're going to now have y equals negative 4/3 x plus 19 over 3. There will be a whole section like this on your test where I'm giving you different information and I'm asking you to write the equation of the line. Can I go on to the next one? Anybody still copying? Okay. Okay, so now this one's saying we want to come up with the equation of a line that's parallel to this whole hot, ugly looking thing and a y-intercept of 1. Well, remember, parallel lines have to have what in common in their equation? The same slope. Right now, I don't know the slope of this line. I only am able to recognize the slope when it's y equals mx plus b. But can I make this look like a y equals mx plus b? Absolutely. So to make this look like y equals mx plus b, we need to get y by itself. You have one of two options. You can distribute in that 4 first and then go from there. Or you, since it's divisible by 4, on the other side, you can just divide by negative 4 on both, divide by positive 4 on both sides. How many people would distribute in? Okay, I think that's majority. So then I'll just do it that way. Both ways work out. I just want to do it the way most people would have probably thought to do it. So we're going to distribute in that 4. So we're going to get 4y minus 40x equals a negative 24. And in order to make this look like y equals mx plus b, we need to get the y all by itself. If I'm going to get this y all by itself, what do I have to move to the other side first? Good. So I'm going to add 40x to both sides. So now we have 4y is equal to, I'm going to put the x first, so 40x minus 24. Have I lost anybody yet? Are we still following? Okay, so now what we're going to do is I still need to get this y by itself. Now I'm going to divide by 4 under every single term. So we're going to get y is equal to 40x divided by 4 is 10x. Negative 24 divided by 4 is a negative 6. So now we have y equals 10x minus 6. So now the new line that I'm coming up to is parallel to this line. So what do we know about the slope of the new line? Same slope. The new line has to have the same slope. How do I know the new line has to have the same slope? Because they told me it was parallel. Exactly. So now we're going to have y equals 10x, and then we still need our plus b, right? Well, they told us the new slope has a y-intercept of positive 1. Isn't that my b? Mm-hmm. So now we have our equation. Y is equal to 10x plus 1. Okay, so this one's really sneaky, but expect to see something like this on your test. Now we're coming up with an equation of a line that has an x-intercept of 8. Well, if it has an x-intercept of 8, how do I write that as a point? Bye. A 0, 8 would be a y-intercept of 8. So an x-intercept would be, switch it, 8, 0. So an x-intercept of 8 is going to be 8, 0. And the other point is 8, comma 5 root 2. I know this is a special case just by looking at the 2 points that exist on this line. How do I know that it's a special case just by looking at the 2 points? Phoebe? Excellent. They have the same x coordinate. So what does that mean? Am I going left or right at all? No. So we can plot this. Let's say you need a visual. You know it's a special case, but you can't remember which special case it is. You can actually sketch those points. So let's say this is 8. This is 0. And I'm just going to make up any point and say that's 5 root 2. All I care is that it's positive, right? 5 root 2 is positive. So the point 8, 0 is here. And the point 8, comma 5 root 2 is here. So what kind of line is this? It is a vertical line. And this makes sense because my x coordinate was the same. So I wasn't moving left or right at all. I was just moving up or down. So now, remember the special case for a vertical line, the equation of a vertical line. We had 2 special cases. One special case was x equals some number. The other special case was y equals some number. Which special case is the vertical line? That's the slope is undefined, but now we're just talking about the equation of the line. X, remember, if you cut the x in half, it looks like V for vertical line. If you turn the y upside down, it looks like H for horizontal. So I want a vertical line. So it's a special case. It's not y equals mx plus b. This was a special case line. So it's going to be x equals the x coordinates. Well, what are all the x coordinates? 8. 8. And that's it. That's our equation of the line. X equals 8. Okay. 2 more together. We want a line that is perpendicular to the y-axis and passes through the point 11 root 3. For a bunch of these, sometimes a sketch is really helpful. So what I'm going to do is I'm going to draw a sketch of what's going on here. All right, so if we're perpendicular to the y-axis and we have to pass through the point 11 root 3, do you think you even need to know what root 3 is as a decimal? No, all you need to know is that it's positive. So if I'm going 11 to the right, I'm just going to put 11 here, and root 3 is positive, I'll put a root 3 here. So the point 11 root 3 would just be here in my sketch. Does everybody see how I just sort of finagled that? It doesn't really matter. Now, I have to draw a line that has that point in it, but not only does it have to have that point in it, it has to be perpendicular to the y-axis. Remember, the horizontal axis is the x-axis. The vertical axis is the y-axis. So what kind of line would be perpendicular to a vertical line? My y-axis. What kind of line would I have to draw? A horizontal line. And it's not just any horizontal line. It has to be a horizontal line that goes through this point. A horizontal line is another special case. What do I mean when I say it's a special case line? It means it's not y equals mx plus b. It's either x equals a number or y equals a number. No y equals mx plus b. So for a horizontal line, is it x equals or y equals? Y equals, remember, turn that y upside down. It looks like an H for horizontal. So it's going to be y equals the y coordinate. Well, what is the consistent y coordinate here? Root 3. You got it. All right, letter F. Contain point 25 and 24.5. Again, special case. How do I know it is a special case? Isabel. Okay, so you're looking into the slope. Yeah. So you're going ahead into thinking the slope without even subtracting. What do I know? Sean? Good. When the y coordinates or the x coordinates are both the same, there's going to be a special case. So what are my two options for special cases? Vertical line or horizontal line? This is saying my y is staying the same. So that means I'm just moving left or right. If I'm just moving left or right, not up and down, what am I doing? Just going horizontal because I'm just moving left, right. So we can sketch this. Even if you didn't figure that out in your head, you do a quick sketch and you'll see it. So we have the point 2, 5. So let's say this is 2, this is 5. And then I have 24, 5. And we put a line through that. It again is that horizontal line. So which special case is the horizontal line? X equals a number or y equals a number? Y equals. And y is going to equal what number? 5, the y coordinates. Okay, your homework tonight. Do you guys see where it says practice? These problems are your homework. That's all it is just those 3. But I do want to show you number 2. I'll do one of them because there's going to be a whole section like this on your test also. Are these lines parallel, perpendicular, or neither? So what we want to do for this section, for the parallel, perpendicular, or neither, we want to put everything or each one in slope-intercept form. How do we put it in slope-intercept form? We have to get what by itself? Y. So I'm going to get y by itself in the 6x plus 2y equals 10. So I'm going to subtract that 6x. So I have 2y is equal to negative 6x plus 10. Then I'm going to divide everything by 2. And y is going to equal negative 3x plus 5. And then for the second equation, I have 3y equals x. I'm going to get y by itself again. So I'm going to divide by 3. Do we all agree there's a 1 in front of that x? So I'm going to divide by 3. So y equals 1/3 x. Since there's no b written down, what would that be? Plus what? 0. So now that I put them both in slope-intercept form, now what you're going to do is you're going to look at the two slopes. I have negative 3 and 1/3. There is a relationship here. What's this relationship? Opposite reciprocals. And opposite reciprocals have what kinds of lines? Perpendicular. If they were the same slope, what kind of line would that be? Parallel. And if they're not opposite reciprocals and they're not the same, then it's what? Neither. Exactly. All right. So we all understand the rest of this page, the rest of the practice problems are your homework. We are